Hi, everyone. We're going to give some highlights from our ELPP 831 Session 3 class. This video will be available for those of you who missed class and for those of you who want to catch the highlights because you liked it so much the first time. So John is also here with me. Say hello, John.
Hello, Tiffany, and I'm ready for an exciting play-by-play recap of our exciting day on Sunday.
But like most good recaps, it's not going to be as long as the actual event itself. So the first thing that we talked about was related to the homework. And I'm going to get back to where I can share my screen so folks can see.
Okay?
So the very first item that we talked about in class was related to especially the bar charts. And we were looking at the data set related to Chapter 4 and specifically Problem 3, where we had the 5 columns of data related to collecting information about students' number of times they were raising their hands within, and it was being observed each day in intervals whereby we collected data 15 times per day. And the goal was to create a bar chart where we were able to have one bar for each day. And that got very, very confusing for a lot of folks. And we had posted a video that was designed to help with that problem. But in working through it ourselves, John and I figured out another additional way to take a look at how to make that bar chart a little bit easier. So what we did was, and I'm going to show you a different SPSS data set, or it'll look different, but it's actually the same data set, but it's set up a little bit differently. And this is going to inform a lot of what we talk about the rest of the time. So I'm going to go back and unscreen share and screen share again the second data set so you can see the difference. The other thing I want to do quickly, I just want to show you the variable view so that you see clearly here that there are 5 variables that we're using in this data set. This is what you pulled out of the Salkind website to do your problem. So let me go to the other data set. While I do that, John, do you have anything you want to share?
Just what an amazing job you're doing here, Tiffany.
Well, you are so kind. Okay, so I unscreen share, and now I'm going to screen share again the other data set that I have up here. Here it is. All right. So let me go over to the variable view first. So what we've done here is created instead 2 variables. The first variable is the days of the week. And in order to do that and do some sort of statistical analysis with it, what we've done is created values over here. So in order to do that, I would have put a value of 1 in the value label part, in the value box. And in the label box, I put M for Monday. And then I added it clicking here. But I've already done all that to prepare for this video. So you can see we have one variable being the days of the week, but we've programmed the options in here for that. Hands raised, the number of times the hands were raised for each of the 15 data points for each day. That's what this second variable is. What that looks like in the data view is this. So if I scroll up here to the top, lines 1 through 15 are all Monday. That was coded as number 1. The hands raised, these are the 15 data points that we saw on the other spreadsheet. And so what I did was I just copied and pasted that data. So the data that corresponded with Monday goes here next to the number 1s. The data that corresponds with Tuesday goes next to the number 2s. The data that corresponds with Wednesday next to the number 3s, and so on. So that's how we set up our data in SPSS, and this will yield, first of all, it'll yield a couple things. It'll yield the bar chart that we're looking for. And in addition to that, it gives us a better opportunity to do some data analysis after the fact, other types of data analysis as well.
So Tiffany, would you go about and how you could do an ANOVA with this data set the way you have it set up now?
Sure. You don't want me to show the graph first?
Oh, sure. I'm sorry.
Okay. Just to finish up the homework problem, we're going to go in and do the graph, the chart builder here. Click OK. Hopefully this will work. Hopefully it won't take too long like it did in class. So in the chart builder, so we're looking to build a bar chart. I double click on the simple bar.
Tiffany, I think you're going to have to unshare and then reshare your screen again.
Oh, really? Okay. Let me go ahead and do that then. So you're not seeing the chart, John?
No, it's doing that flash thing.
Okay. So why don't you talk a little bit about the ANOVA while I'm getting there?
All right. So if you can think about how you do the compare means various testing, you have to have an independent and a dependent variable. And it's set up as two variables. That's you have the independent variable, which is for days of the week.
Sorry about that.
And you have the outcome variable, which is raised hands. So you have the dependent and independent variable with the two columns set up, and it's ready to go in SPSS. If you were to try to do a compare means with the 5 variable setup approach, you can't do it in SPSS because it's not set up in the logic that SPSS is looking for, which is independent and dependent variables.
That'll be better. Oh, what are you all seeing now, John?
I'm seeing your Hangout screen.
Okay, that's fine. That'll work. So here I am. Do you see the chart builder now?
Sure do.
Okay, excellent. So the days will go in the x-axis, if you remember, to drag it down like the video that was posted showed you. And then the count, we bring the hands raised over into the count. Now, I changed this in the, after I build the chart, I'll show you that I changed it to be a scale variable. It didn't identify what type of variable it was, but I had to set it to the scale to be able to do anything with it. So I want it to be the sum, because if you remember, the directions for the homework problem said create a bar chart that shows the number of times the hands were raised per day, meaning adding up the 15 data points per day. So once I've gotten everything in place, it should change over to the sum here. I'm not sure why it's not doing that. Let me share it again.
I cancel that, Tiffany, because
yes. All right.
I think it's not in there at all right now. Okay.
Yes. All right. Let me see if I can change that statistic again to sum. That would be how you do it. I'm not sure. Oh, apply. That's what I have to do. Sorry about that. So I just clicked apply in the bottom left corner, and you see it's now changed to sum. So now I have everything I need, I believe, to create the bar chart we're talking about. And in my back window here, we've got the bar chart popping up, hopefully. There we go. And so that was the correct answer for that number 3 problem in chapter 4. Now, what John wants to ask me to do is to go show you how to do the ANOVA, running the ANOVA with the data set up this way, because you wouldn't be able to do it with the data set up the other way. So when I go under Analyze, I then click over to Compare Means. And we did the one-way ANOVA, correct?
Right.
Click on the one-way ANOVA. And so the dependent variable was the hands raised, right?
Yep.
And what we wouldn't have had, the way the data was set up before, we wouldn't have had the dependent variable isolated like this. And the days goes down as the factor. And then we can run that. And we're able to get the ANOVA the ANOVA taken care of here. We run the ANOVA here so we can see the statistics come up for the one-way ANOVA, which we would not have been able to do had we had the data set up the other way.
And in this particular case, it turns out that with this sample, it doesn't turn out to be statistically significantly different between the days.
Right.
And that looking at the 0.44 number there.
So if it were statistically significant, that number right here in the SIG column would be 0.05 or less. So that's how you know that.
So the reason we're recapping this is because this idea of the 2 variable setup versus the 5 variable setup could come into play anytime you're collecting data. There's a general rule about how you set up data in SPSS, and the general rule is 1 row per participant. Oh, I think I'm going to mess things up here. So anyways, how about if I change that to the general rule? Be thinking about have columns for your dependent and independent variables.
That's a good way to say that, John.
All right.
I'm going to unshare now. Switch over to you.
All right. So that was the first exciting event that happened on Sunday. And I think all the fans that were there live remember it well, right?
Absolutely. I mean, you can just hear the cheering in the background. I can hear it.
All right. Now, the second thing that we did was we worked with figure 9.1 and in the textbook. And I guess this whole day had 2 big ideas. One of them was being able to, given a particular research question, follow that figure 9.1 map to the right statistical test. And the other big idea is the difference between effect size and inferential tests. Right? But that first idea about being able to follow the map, that was a big idea for that day, but it's a big idea for this course. And I would even say it's a big idea for the sequence of research methods courses. Mm-hmm. So we're doing a lot of practice with you about how to calculate. And that's useful and it helps build understanding. But the truth is, SPSS will do those calculations for you. But what SPSS and no one can do for you is help you figure out what's the right question you should be asking, and then how to match that question with the statistical test. So the figure 9.1 is really essential thing for you to understand. We want to have exercises for you to make that more your own, and so that you can think more fluidly, given any kind of research question. What would be this appropriate statistical test?
And if you, as we read on in the Salkind text, you'll notice that figure 9.1 is replicated, and in addition, little pieces are added to it along the way. That's how key of an understanding it is. So for those who may want additional work with that, especially those 3 who missed class, we're going to offer an opportunity to come in and complete that activity again, we think prior to class beginning at our next session in April.
All right, but let's try to ask a question now, Tiffany, to kind of prime the students to be ready for that. So okay. What we asked in the live session was, first we used the TPACK data set that we're pretty familiar with to come up with examples of how you would follow the map based on different questions. And then we came up with a question unrelated to TPACK to see if we could do it with another topic. So, for example, if you think of the TPACK data, could you come up with some variables that would be appropriately compared in the research questions that would go with them? Or just doing a dependent variable, a dependent t-test versus an independent t-test? Could you do one for ANOVA? Those are the 3 easiest. Some of the other choices in that map get a little bit trickier, but just those 3. So should we give some examples, Tiffany?
We could. It might be helpful to go over to the PowerPoint. Do you have that up for the?
I do. Oh, let's see here. Let's see if I can bring it up.
Okay.
I'm not sure it's going to help us, but let me try.
Well, what we're explaining is associated with the couple. There's a PowerPoint presentation in there related to the activity that we did. Actually, I can find it quickly.
Are you talking about the map?
Yeah, so that at least they can see what we were talking about.
Your 9.1 map.
Oh, I see what you're saying. Yes. Okay.
Well, I don't think we have it handy, do we, Tiffany?
No, we don't.
But for example, if you were to think of the TPAC data, what would be an appropriate question for an independent t-test statistic? You want to offer one, Tiffany, or?
I was actually looking. I thought I might have saved that graphic. Why don't you keep going? I'll see if I can find the 9.1.
So I'm doing the figure 9.1 from memory, but for an independent t-test, you're asked the question, is it a repeated measure or not? And in an independent t-test, it's not. And are you comparing groups or not comparing groups? This is in the comparing groups range. And what else? So basically you're comparing groups, and it's 2 groups, not 3 or more groups. And you're not doing repeated measures, and that's the independent t-test. So what would be a question you would ask there? You would have to either pick the pre-test data or the post-test data, because you're not doing repeated measures with an independent samples t-test. So I'm going to pick the post-test measure. You'd have to pick one outcome variable. You got lots there. I'm going to pick the TPAC total scale post-test. And so the question might be, and you're only comparing 2 groups, so you can't compare all 5 groups. So the question might be, is group 5 significantly different than group 1 on the TPAC variable? And I might expand that question a lot more to include a little bit more explanation about what happened in semester 5 versus semester 1, but that's the essence of the idea. That would be an independent t-test question and the matching statistic.
And in the dependent t-test, that's where we have the repeated measures. So you would be comparing a group's scores from the pre-test to the post-test, whether it be the semester 1 students or the semester 2 students. But the hallmark of that dependent t-test tells us that we've got repeated measures involved. So you would be utilizing those types of data for the TPAC. We had lots of options, and of course in the class session we had lots of different correct answers that fit when we went through this exercise with folks.
And so what we would ask you to do in preparation to that meeting we're going to schedule later is see if you can go through the TPAC data set and think of what's a correlational question that you could ask, what's a regression question, different kinds of t-tests, and the ANOVA. Was there any other ones in that figure 9.1, Tiffany?
I don't think so. Not that I can think of off the top of my head now.
All right. And then after we went through that and kind of like, we checked understanding because it gets confusing.
Mm-hmm.
And then we tried it again with another question. And it's kind of like you just have to practice at it. But eventually it starts to make sense where you can think of a question and think, oh, that's the appropriate statistical test. And that's what we want you to be able to do.
And if you want a preview of that, you can take a look. There's a PowerPoint in the face-to-face files on the D2L, and it's the 830. It's the one that's the PowerPoint slideshow that's labeled ELPP 831 Session 3. It's got the information related to those 2 activities in there, and you might be able to get an idea using the slides there also in preview for the session we'll set up.
So Tiffany, am I right that the next thing that happened and that the last thing that we're going to talk about today is calculating effect size and what that means compared to t-test?
That's right. That was the last very exciting thing that we went through in class, John. You got that.
All right. All right. So let's do that. And I'm going to bring up the PowerPoint that we used. Actually,
okay.
What we're going to want you to do as we present this is have you download this PowerPoint so you can look at it independently, probably stop the video a few times, and also download the Microsoft Word document that looks like something.
It's the only Microsoft Word file, I think, that's in the files for the class session.
We're talking about the face-to-face.
Yes. Mm-hmm.
All right, this file here. You're going to be working with this file and doing calculations. We're going to explain a little bit in this video how to do them and why we're asking it. But you want to have this prepared before you watch any more. Okay, the PowerPoint and this.
Mm-hmm.
Right? All
All
right.
right.
Sorry for the inefficiency here.
What I found to be most successful, John, when I was having an easier time sharing my screen was when it said share total screen, and then I could flip back and forth between different things.
Okay. I will do that.
That was an option that I finally figured out.
Whoa. That didn't work.
Wow, that looks awesome.
That's exciting. I'm making All right. So this is a question that we asked at the beginning of class, and really we're building towards you being able to answer it. Right now, it's going to be a difficult question and likely come up with the wrong answer when you're doing it, but want to kind of get your minds in the right frame of mind. So we're talking about effect size and t-test. We're going to do calculations. You're going to see the differences to the calculations.
Hey, John.
Yeah.
The PowerPoint's not up that I can see. I see your face frozen, which is great.
Yeah. No, but I'm seeing it on mine. Nope. I'll try again.
Okay.
Thanks for sending that, Tiffany.
Sure.
You see it now?
I still see your face frozen. Oh, there it is. Perfect. We got it.
Frozen. All right. So we're going to go through calculations, and you'll be able to tell, oh, this formula is like this, and this formula is like that. But what does it mean? I mean, you don't even need to know to calculate in order to know what it means. So if we were to ask you now, what is effect size and what does it mean? And how is that the same or different from what you are doing when you're doing an inferential test like a t-test or an ANOVA? We have covered effect size, and in the last couple of chapters, we did talk about what does doing an inferential test mean. So it's possible to answer this, but I think you might be a little bit surprised at the answer. Right, so pause the video and just think about that, and then we'll give kind of a misconception that almost everybody in the class had, and then maybe a little different way of thinking about it. All right, so Tiffany, you want to start it up again and then talk about those, what everybody kind of seemed to think it was, but what it really is?
Well, sure. So when we were trying to find out the difference, so what an inferential statistic was, everybody kept saying things related to how different they were. So how much bigger was one than another, was the result of one group of results than the other group of results. And we kept saying, that's effect size. And every time somebody said something like that, we kept saying, well, that's effect size. So we've been talking a lot about the degree to which something is bigger or smaller than the original data set results. But what it turns out to be, finally, was that it just comes down to, is there a significant difference? So it's a yes or no.
Yeah.
The inferential statistic is a yes or no.
You say that, Tiffany. I see why so many people are misunderstanding it, because the word significant is part of your answer there in the yes or no. And of course, people think significant means important,
Large.
or big, or how big.
Right.
But it doesn't mean that. It simply means whether or not you pass that critical value that has been set up, at whether P is less than 0.05, for example. That's a yes or no question.
But in the scientific community, that's all that's important, right?
Well, I mean, I guess it depends on the question and how it's interpreted. But yeah, that's the bottom line for most researchers. Right?
Well, luckily for social scientists, we have a little bit of a different way of looking at things. That statistical significance it gives us information, and it certainly is important to a degree, but the effect size, which gives us a different understanding of our results, is also just as important, if not more, in a lot of cases.
So one of the things that we're going to end up getting to in this is, can you have statistical significance without a big effect size? Or can you have a big effect size without statistical significance? Or do they always go together? And what do the two things tell you that are different? Okay. So back to our practice, I could get good at this. All right. We're going to get at this first by calculating effect size and seeing how that is and how it's different from t-test. So we're going to actually have you do this. This is where you're going to need the Microsoft Word document. In the Word document, these values that I've got here are already in there. And you're going to first calculate the standard deviation and then use that to calculate the effect size. So remember, when you're calculating standard deviation, the first thing you have to do is find the average of each group. And then there's no really place in the document to do that. So you got to calculate the average first and then subtract that average from each of these scores. I think I remember that the average for the first group was 74. Does that sound right, Tiffany?
That does sound right, yeah.
Okay, so if you get something different than 74, you're probably going off track here. So, but in the Word document, you're going to take 73 minus 74 and get -1, and then you square it, and you get 1. 78 minus 74, you get 4, and square it, and get 16, and so forth. Let me bring that back up. All right, so you're going to put 74 in here. Oh, deviations from the mean. So you're going to do that calculation, 73 minus 74, put -1, 4, 14, etc. Going down here. Then you're going to square them. You got to add up the squared deviations. Here's the formula here. Divide by n-1. There's 8 here, so n-1 is 7.
Hey, John, I don't see the sheet. I just see your face again, which again is great.
Okay.
There it is. Perfect.
I'll bet. See it now?
Yes, I see it now. There's a bit of a delay when we do that.
Probably my face is better though, right?
Absolutely.
Okay. All right. So again, this is where you're putting the 73 minus 74 here. 4 would go here, 16's going here, etc. When you get down here, you total up the squares, divide by n-1 to get the variance, n being 8, and then take the square root to get the standard deviation. Both of these numbers here and here, the variance and the standard deviation, are going to be used later in some other things we're going to do. So these are the two numbers you're trying to get at, both for the control and the treatment. So I would pause the video now and calculate all that up. All right, so what we're going to have you do next is calculate effect size, and we have 2 different formulas for you to do effect size. One is the simplified version of the formula that I presented last semester, and that is effect size, which is a lowercase italicized d, equals the mean of the first group minus the mean of the second group divided by the standard deviation of the control group. So I think this group turned out to be 83 average, and this was 74. So 83 minus 74, you get 9 in the numerator, and then the standard deviation of the control group. I think I remember that turned out to be 11.69.
That sounds right.
Okay. So that's your first effect size calculation. This is a little more sophisticated way of calculating effect size. Instead of dividing by the standard deviation of the control group, you do a pooled standard deviation, which is something like an average of the 2 standard deviations. The way you do it is the s lowercase 1 squared there is the variance of the first group, not the standard deviation, but the variance. So you add the variance of the first and the second group, you divide by 2, and then you take the square root. What you're going to find is that the effect size for both of these is pretty similar. It's a little different. But remember, when we're looking at effect size, we're looking at general guidelines of whether something is big or small. So I think you're going to find out that the effect size calculated this way is 0.7 something, and the effect size calculated this way is 0.8 something. And really, they're in the same ballpark and giving us the same information. Tiffany, what would you want to add to that?
Well, knowing that the effect size is a 0.7 something or a 0.8 something just really tells us that there is a pretty large difference in between the means of that second group as opposed to the means of the first group. And that's going to be important to remember when we then go down and calculate the t-test value.
All right, so we find out the effect size is 0.7 or 0.8, which we know is large. And David's probably saying, that's very large. And you tried to trick me on that quiz question before. I don't know if it's large or very large. So what? We tricked you. All right. Question is, okay, you know the effect size is big. Does that mean that it's statistically significant? And another way of looking at that is, can we reject the null hypothesis given that we know this much? The averages and the standard deviations. Yeah, there's the numbers right there.
Yep. That
you should have come up with. Or visually, you might look at it as two normal curves, one for the control, one for the treatment. And the treatment is shifted over a little bit to the right. Question is, and there's some area that doesn't overlap and some area that does. Kind of like, are those two really different, or is the overlap such that this difference could have happened by chance? And that's what the t-test is going to tell us. Okay.
And in order to eliminate that null hypothesis, you have to have the p less than 0.05 value for statistical significance.
All right. So we're going to have you calculate the t-value 3 different ways. We're going to have you calculate it by hand. We're going to have you calculate it using a website that helps with the hand calculation, and we're going to have you do it with SPSS. Ideally, we're going to get the same answer 3 ways, but doing it 3 different ways, I think will help bring home the meaning of how it's calculated. All right, so first by hand. Whoops. First by hand. We're going to calculate the t value, and after we do that, we have to use a chart to look up whether it meets the 0.05 criteria. The formula is the mean of the first group minus the mean of the second, so you notice that's very similar to effect size. And then it's going to be divided by variance of the first group, not the standard deviation, but the variance, divided by the number in the first group, so that's 8, plus the variance in the second group divided by 8, so there was 8 in that group as well, and then take the square root of that. Go ahead and calculate that, and after you calculate it, you're going to look that number up on page 371 in your textbook. Although I'm going to bring up a website here that has the same chart on it. But pause the video and calculate the t-value. Tiffany, you want to talk through the t-values when I bring them up here?
Sure.
My ships. You see it?
Yes, I see it. It's small on my screen, but I do see it. So what you have to do, one question revolved around, well, what are the degrees of freedom? How do we figure that out? So the degrees of freedom are the total number of instances minus 2. So in this case, we had 8 scores in the treatment group and 8 scores in the control group, which equals total 16. So we had 16 total scores that we're talking about. Minus 2, so that's how we find out the degrees of freedom. So 16 minus 2 is 14. So, that's beautiful, John. Thank you.
You see my mouse there?
Yep. So that's where John's pointing with his arrow. So then what we look for is statistical significance means that we have a value of p less than 0.05. So the t statistic you end up with at the end of your calculations needs to be less than 2.14.
More than.
What's that?
It has to be more than.
Yes, sorry. It needs to be more than the 2.14 in order to be considered statistically significant result. Now, if you did the calculations right, if I remember correctly, you should have come up with something like 1.71
right,
as your t-value, which since that is less than the 2.14, that means that your result is not statistically significant, meaning that you must accept the null hypothesis and that there's no difference between the scores.
Right. So
and that
go ahead.
That in itself is fascinating to consider when we look at the fact that our effect size that we calculated was a 0.7 or 0.8, depending on which calculations you use.
Right. I had the, let me bring that other website up. I had it up.
Okay.
All right, I have it again. So we're gonna have you look at another video that we'll send you a link somehow that talks about calculating the same sets of data using this website here. This is the second way we want you to do it. But essentially what you're gonna do is put all the values for the control group in the X here, and then all the values for the treatment in the Y. And then what you do is you keep clicking these buttons, and you wanna make sure you understand what happens when you click each button. So when you click the sum X, it's gonna add up all the X values and put a number here. And when you click the mean, it's gonna give you the average here. And then click deviation scores, and it's gonna do all that, essentially all the same work you just did. It's gonna do it here, but it's kind of nice to kind of see it step by step being done by somebody else, so it kind of makes sense of where those numbers came from. Eventually, it's going to give you the variance here and the variance here. Right? Where's the standard deviation go? I don't know. Just keep clicking all the buttons. 1, 2, 3, 4, 5. Then it's going to put it into the t-test formula. Right? It's going to put the mean of one group here and the mean of another group here and the variance here and here. And then it's going to kind of do the math for you until you get down to a final t number. If you've done it right, hopefully you're going to get the same answer here that was produced when you did it by hand. And then you look at the probability table, and again, it's 14 degrees of freedom, the same cut number, and your number probably will not be there if it's done right. Therefore, that's another way of calculating that it did not meet the p less than 0.05 criteria.
But when you watch the video, it's going to give you some additional information that will give you a kind of an aha moment that we had in the last rushed 10 minutes of class with the rest of the group.
All right, so the last way of doing it is with SPSS. And notice I've got the same data set up here. Here's kind of the aha, I think that Tiffany was talking about, one of them, is again, we're not setting up, we're setting this up in with two groups. I mean, excuse me, two variables, the independent variable and the dependent variable. So you got to get used to thinking like that when you set up your data in SPSS, and that's going to allow us to run the t-test. So you can't see now, but I'm doing the compare means, and I'm doing independent samples t-test, and my grouping variables here. Now, unlike the ANOVA that Tiffany did earlier, it wants to know which groups am I talking about. That's what the question marks mean.
And John, that part's not showing right now. All I see is the data set.
Oh, okay. Well, when you do the independent samples t-test, it's going to ask you for the groups, and you got to put in group 1 and group 2, even though there's only 2 groups. Okay. And so I'm running the test now. Is my output coming up, Tiffany?
It is not, because it comes in a different window. You have to click over to the other window.
I stopped sharing my screen or not?
No, I see the data set. That's all I see, is the spreadsheet.
I guess I'm gonna have to do this. Now you see it?
Not quite yet, maybe in a sec. There it is, yep.
All right. So you see, we got the same values again here. We got the t value is 1.7. We got the degrees of freedom is 14. In our other ways of doing it, we just knew that it didn't reach the 0.05 level. Here, SPSS gives us a specific significance level that it does meet, 0.109. Tiffany, you want to talk about the negative sign here?
I was just going to. You read my mind, John. So what you see there, I know it looks different, but all it means is that SPSS is saying that it's taking the difference of the treatment away from the difference of the control group. So it's just ordering it, but in a negative t-score versus a positive t-score, it doesn't really matter. It's still the same number, about 1.71, and it's just negative here, but it doesn't make a difference in the calculation of the significance calculation or anything else, honestly. The degrees of freedom are the same. Everything else is the same.
So notice that this is significance two-tailed by default. You actually can't do one-tailed in SPSS. And so if you were writing this up and interpreting it, really the interpretation is that the control and the treatment are different. And you know that the treatment was higher than the control group, so you can state that. But since it wasn't a one-tailed test, you can't really say that the comparison demonstrated that beyond the 0.05 level that the treatment was better than the control, just that it was different. If you were to do a one-tailed test, you would have to really get a significance level instead of 0.05, you'd have to get a significance level of 0.025. Clearly, we don't get it either way here. Now, so we came to this point, this is close to where the day ended on Sunday, and we've had the situation that the effect size was large, but it was not statistically significant. Right. Tiffany?
And so what the last video will show you that we'll post is an explanation for that. So when you go back to the formula, you'll see that part of the denominator, John just pulled that up, relates to your n's, your sample size. So when you go through the Psychology Today t-test calculator, the video that we'll post has some narrative in it from whether it's John or me who made it. I'm not sure. I think it'll be whichever one we find first to send you. But that narrative will talk you through the process of what it looks like as you change the sample size. Because as you change the sample size, we'll mathematically change the calculation. This is pretty much where we did end class, where we rushed through a major aha moment that shows that when your sample size is larger, that impacts your t-score, certainly. And so you're dividing by, when it all calculates out, you end up dividing the difference in the means by a lower number, which then makes your t-score higher. When your t-score is higher, you have a higher likelihood of reaching statistical significance. Did I say that right, John?
Yeah, it's all right. Let me just say it another way, because it's, I think we come at this a lot of directions. I'm actually going to quote Dave because I thought he had a nice way of saying it that made probably pretty clear. When you look at the effect size here, n is not part of this equation, but it is over here. So sample size affects the t-test quite a bit. It does not affect effect size at all. So the reason we had a big effect size here without having the t-value be significant was because we just didn't have enough, I'm quoting Dave here, we didn't have a large enough sample to produce statistical significance. With a larger sample, even if the effect size stayed the same, we would have had statistical significance. And Tiffany, I don't remember that video really walks through that.
I think it does.
Okay.
I think there's a version of it somewhere that does.
Okay. I'm going to do it here anyway.
Okay.
All right. So, all right. So here's the data set, and I've copied it, and I'm going to paste it. All right. Same data set. So the effect size should be the same. I just have 32 values instead of 16. I'm going to do it again. I'll have 64 values. If you think about it, the average is going to stay the same because I'm just using the same numbers more times. And the standard deviation is also going to stay the same because the distance of each point from the mean is still the same. Am I showing what I think I'm showing here, Tiffany?
Yes. Well, you're showing the data set right now that's copied.
Okay. All right. And now I'm going to run the statistics, same one we did before. And I think I do have to switch my screen, right?
Yes, correct.
All right. So notice mean 74, standard deviation changed a little bit. I'm not sure why. And 83 and 8.72.
It's about the same.
What? Yeah, but what? Why did that change? I guess it's the n-1 is making a difference. All right.
Mm-hmm. Well, yeah, we have a different degrees of freedom.
Well, yeah, when we're dividing the standard deviation, we're not dividing by n, we're dividing by n-1. So 8 minus 1 is 7 versus 32 minus 1, it's making a difference, a slight difference there.
Yeah.
But the important point here is, here's the significance, 0.01. So even though the effect size is really the same, if we were to calculate effect size, very, very close, slightly different. But now there is significance. So this
as you see, that t-score is over twice as large as it was before with the higher number of participants that we're calculating in here.
And essentially the only thing that changed was n, right? So
that's right.
So here's a case where we have statistical significance and a large effect size. And in the other case, we had a large effect size, but no statistical significance.
Now, this is what the testing companies and those textbook companies, that's what they need to show us.
Which part do you think, Tiffany?
That's how they can get their research to be up to snuff by having more participants. So then they can show the statistical significance and an effect size instead of those cheesy charts that all of you dug up that we found.
Yeah. So at least for my money, effect sizes, I really do need to know both. Like Tiffany said it really good at the beginning. The t-test is important information. And you need to know it, and you need to know the effect size also. But in terms of making a decision whether or not to do something, effect size to me is probably the more important bit of information, because you want to know how big, not just whether or not it was by chance, but how big the effect is likely to be. So you can have just the opposite situation than what we just said. You could have a small effect size, very small, almost meaningless or meaningless, and still statistical significance if you had a large enough sample. That n being in the denominator there is really going to affect everything quite a bit.
So as you read, as educational leaders, as you read the information based on some of these programs, you want to really pay attention to both. Because if it says our program demonstrates without a shadow of a doubt statistically significant differences, look at that sample size. If they have a sample size of 1,000 or 2,000, pretty much anything they do will have statistical significance. And now that's something that you should know. But what's that effect size? Are they reporting that? Because if they're not reporting that it would be a clue to me that the program isn't actually that effective.
And the opposite, the reason we want both, let's say I was to tell you, I did this experiment, I had effect size of 0.9. Well, and I had 8 participants. So I didn't have statistical significance because my sample size was too low. All right, well, that's interesting, but it was only 8 people. Could you replicate that? I don't know. So that's why you want also to have a big enough sample to prove statistical significance. Ideally, you would want both.
Mm-hmm.
All right. Wow, that was an exciting day.
It was. Think about those highlights from our class session and more to come.
Yeah. All right, so we're going to post this for you and post another video for you, access the materials, and hopefully arrange to have a meeting before class the next time we get together.
All right. This is Tiffany Wright and John Ward signing off.